welcome to all my dear students. Students, in today's lecture we are going to talk about carbonyl amine reaction. So let's start. We'll discuss carbonyl amine reaction. First, we need to know that this carbonyl amine reaction is a detection test of primary amine functional group. Yes, दोस्तों, this carbonyl amine reaction is called detection test of primary amine. Let me mention this point. This carbonyl amine reaction is known as detection test of primary amine, whether it is aliphatic or aromatic. For both aliphatic as well as aromatic amine, this test is used as a detection test, as that of Lucas test used for the detection of alcohol. This carbonyl amine test is used for the detection of primary amine, whether it is aliphatic or aromatic. So let's start the reaction. First, to perform carbonyl amine test for primary amine, we'll take primary amine, any primary amine. As I told you, it is aliphatic as well as aromatic. Then we'll add chloroform and base. We'll add CHCl3 and 3 mole of potassium hydroxide. We'll heat the solution. By heating the solution, there is a removal of potassium chloride, there is a removal of water molecule, and there is the formation of isocyanide group. Come on, there is a removal of, come on, see, if we need to understand by short method, we can say that 3K plus removed from this base with 3Cl minus, that is removal of 3 KCl plus with this 3K plus ion, there are 3 OH minus ion present. How many OH minus present? Come on, there are 3 OH minus, 3 OH minus, and see, there are 2 plus 1. How many hydrogens present? There are 3 hydrogens present. So come on, from this KOH, 3 OH minus, and from this amine and from chloroform, there are 3 hydrogen. 3 hydrogen with 3 hydroxide group. Ultimately, there is a removal of 3 water molecules. So what is left now? From here, Rn plus and C minus group is left, which will combine to form isocyanide group. Come on, this is called Rn plus triple bond C minus. This group is known as isocyanide group, or it is known as isonitrile group, or it is known as carbyl amine group, and this is foul smelling compound. Come on, this is foul smelling compound, bad smelling compound, that is isocyanide or isonitrile group. Do remember, so this test is used for detection of primary amine. Now again I'll repeat, this is the short method to remember this carbonyl amine test. This is not the actual mechanism. The actual mechanism for this reaction I am going to explain you. So in the mechanism of carbonyl amine reaction, first chloroform, that is CHCl3, is reacted with 1 mole of base. Now friends, we know that this electron rich side will attack over electron poor side, that is H from chloroform, will react with this base, and this 2 electron of covalent bond will shifted over this carbon. But we know that carbon is electropositive, so it will accept electron and it will donate this covalent electron to one of the chlorine molecule. So ultimately there is a removal of OH and H, that is water. Come on, there is a removal of this chloride ion Cl minus. Now what is left? This carbon contains 2 Cl, that is CCl2, and 2 electron. It will gain from the covalent bond between carbon and hydrogen. So we'll get CCl2 with 2 electron. This species is called this is called dichlorocarbon. Come on, this is called dichlorocarbon. And friends, we already know that this carbon is electron poor, it is electron deficient, so it is known as electrophile. Why it is called electron deficient species, electron poor species? Because it contains only 6 electrons. We can see that this carbon contains 2 Cl, means 4 electron of covalent bond, 2 covalent bond means 4 electron, 5 and 6. So it contains how many electron? Come on, it contains 6 electron. So it is electron poor. So it is called, it is called electrophile. I hope up to here you all understand what I am trying to explain you. By reaction of chloroform with base, it forms dichlorocarbon. Now we can see that there are 3 mole of bases used in this reaction. Now furthermore, this dichlorocarbon will attack over this primary amine. Now let me write the further mechanism. RNH2. This nitrogen contains a lone pair of electron, and there is a dichlorocarbon CCl2. Come on. Now, which is electron rich side and which is electron poor side? Again, because we know that in a mechanism of organic chemistry, we have to understand this fundas, electron rich side and electron poor side. So this is electron poor side. We already mentioned here, and this is electron rich. So nitrogen will attack over this carbon. So nitrogen again will attack over this carbon. So what we'll get? We'll get R, and there are 2 hydrogen present with nitrogen, and the lone pair of electron will attack over this carbon. So carbon with 2 Cl. Come on, carbon contains 2 Cl. This 2 electron will be shifted over this carbon. So there is a formation of covalent bond between nitrogen and carbon will be partially negatively charged and nitrogen will be partially positively charged, because nitrogen, the valency of nitrogen increases by 1. We know that valency of nitrogen is 3, but here in this case we can see that the valency of nitrogen becomes 1, 2, 3 and 4. So valency increases by 4, so nitrogen will be partially positively charged. Now as I told you earlier, there are 3 mole of base used for carbyl amine reaction. So now what will happen? This base OH minus, this base OH minus will attack over this acidic hydrogen, and again this another base OH minus will attack over this hydrogen. So ultimately there is a remole of 2 OH minus will attack to 2H plus. So there is a remole of 2 water molecule. 2 water molecules plus there is a remole of 2 chlorine. 2 Cl minus, and there is a formation of 1 bond over here and 1 over here. So we'll get Rn plus triple bond C minus, and this functional group is known as isocyanide group or isonitrile group, or it is called carbyl amine group. This is called isocyanide, or it is called isonitrile, or it is called carbyl amine group. Now friends, there is a small confusion in this reaction. There are so many students over there which are thinking right now that the secondary amine will react with chloroform and base or not. Secondary amine will again in this case, if we'll take secondary amine, it will react with chloroform base or not. Now friends, in a case of secondary amine, we know that there are only one hydrogen present in a case of secondary amine. And you can see that there are two hydrogen atom needed for this reaction because the base is in excess. So base should react with more amount of hydrogen, and here in this case in a secondary amine there is only one hydrogen present. So there are no more hydrogen present, so the reaction will not proceed and it will not give isocyanate group. So in this secondary amine, come on, in this secondary amine, carbyl amine reaction is not possible. Come on, carbyl amine reaction or test we can write. Reaction is not possible. I hope you all understand this. Now you can write any example by taking different alkyl or aryl group over here. Let me mention a reaction. Will take aniline, structure of aniline, that is benzene dash NH2. Will take chloroform and base. Now let me tell you, in the competitive exam they had written in this way: chloroform plus OH minus. They won't write exact mole ratio, that is 3 KOH or 3 OH minus. We need to understand this. So ultimately in a conversion, in a short method, we need to remember that this primary amine on reaction with chloroform and base, this NH2 group, come on, this NH2 group will be converted to N plus and C minus. So come on, we'll get benzene and plus triple bond C minus. And the name of this compound is benzoisonitrile. Come on, this is called benzoisonitrile, which has foul smell. So by smelling this compound, we came to know that primary amine is present. So this again carbyl amine test is used for the detection of primary amine, whether it is aliphatic or aromatic, and due to less number of hydrogen atom in a structure of secondary amine, in a secondary amine, carbyl amine reaction is not possible. I hope it is clear to all of you. Now the next chemical property of amine is reaction with nitrous acid. Now let me remind you friends, in haloalkane and haloarine chapter we already studied this reaction, the reaction of aromatic amine with nitrous acid, that yields benzene diazonium chloride, and this reaction is known as diazotization. So in this video lecture of carbyl amine reaction, I'll provide you the link of this diazotization reaction for the production of BDC from aniline. So please go in the description of this video and you will find the link of the particular diazotization video lecture. Thank you friends for watching this lecture.